All right, so I think we were all in class when we, I don't need to go over these limits again. I will tell you the answers just in case you need to go back and check. -11/4, we just plugged in 3. We did some factoring. Of course, you could probably use L'Hopital's as well, but we got 7/4. Here we multiplied by the conjugate, so radical x plus 3 and radical x plus 3. But in the end, the x minus 9 canceled with the bottom x minus 9, and we got a final answer of 6. Here we did some algebra, and we got the top to have a common denominator, so it allowed the h to cancel right here, and so what ended up happening is we got -1/25. So you can go back and check the class video if you need that, the Zoom video. All right, so we talked about continuity. Back in algebra, in calculus last year, you learned continuity. You need 3 things. You need the function has to be defined at the point you're talking about, the limit has to exist at that point, and the limit of the function at the point has to match the function's value at that point. So those 3 rules for continuity. Usually there was probably like an AP question about that, right? So these things that we did with limits up here, plugging in, factoring, conjugate work, algebra work, you can do those things, and sometimes you have to use L'Hopital's as well, but sometimes there's no other tricks to do. So for these limits we're about to do, so you have to do other things. So let's take a look at these. So down here, we're going to have to be able to do the limit of these items here, because that also is what our continuity is used to. We need to be able to do limits to do continuity. So here we go. So I plug in 1 and 2. So if I plug in 1 and 2 here, I end up getting 8 on top, and I plug in 1 and 2 down below, I'm not going to get 0 is basically what I'm worried about. When the denominator is 0, I can't do anything with that. So this is just basically a plug-in. I plug in 4, I got 4, 1 and 2, so that makes 8 up top. And the bottom, 3 times 1 squared, so 3, plus 2 squared is 4. So 3 plus 4 is 7 down there. All right, so that's just a regular old easy peasy. Over here, letter B. So back in calculus, you memorized this, right? The limit as x goes to 0 of sine x over x was equal to 1. You could also look at the graph of this thing, the graph of sine x over x. It kind of like twists around, but then it comes up and has a hole here, and then it comes back down and twists around. And so basically that value that it approaches is 1. It doesn't exist at 0, but it approaches 1 from either side, so you're able to say the limit is equal to 1. All right, so what we can do then is we can separate this, because if I plug in 0s and 1s right now, I get 0 on top and I get 0 on bottom, which is no good. So I can rewrite this as limit as x, y goes to 0, 1. You're supposed to write that. I know it stinks. And what we can do is like separate these parts. Let's do the y over y plus 1 here times sine x over x. And so now I'm just basically worrying about this part as x is going to 0 and worrying about this part as y is going to 1, right? And so I can kind of separate it into 2 different problems. Well, this right here is like we got up here, so that's 1. And then this front part, I can just plug in 1 over 2. All right, so that's how I get my limit there. All right, back over here, I'm going to do some factoring. I noticed that y squared minus 4 is y plus 2 and y minus 2. The bottom I can take out an x, leave me y minus 2. All right, so that is what the problem was. If I plugged 2's into these, I ended up getting 4 minus 4, and up top I also got another 0, so that was the part that was making that happen. So now when I plug 2 into everything, I get 4 on top and 2 on bottom, so 4 over 2 is 2. Okay. All right, over here, I'm going to do that separating bit again. Because right now when I plug in 0 for cosine y there, 1 minus cosine of 0 is 1 minus 1, so that's 0. And I put a 0 here, I get 0 over 0. So I can use a form of L'Hopital's eventually, but I can't do it yet because everything's mixed together. So let's do like we did up here. Limit as xy goes to 2, 0. So I'm going to write it as 2 different parts, 1 minus cosine y over y squared, and over here is 1 over x. So this 1 over x right here is not bothering me at all. That's just going to be 1/2, like I already know that right now. Okay, but it's this part. So couple things I can do. Well, first we got to start off with L'Hopital's, right? If I plug in 0 right now, I get 0 on top and 0 on bottom. So 0 over 0 is indeterminate, so I tell you that I'm doing L'Hopital, so write a little LH. So remember, for L'Hopital's, I do the derivative of the top, so that'd be 0, minus derivative of cosine is negative sine, so minus minus makes plus a sine. Okay, and then the bottom I have 2y. I don't do quotient rule, I just do the derivative of the top, derivative of the bottom. All right, so I wrote an x, it should be a y right here. So, do you notice this? Look at that sine y over y. That's this. So you could do one of two things here. You could notice that, and notice that you have a 1/2 times a 1 basically, and then you have another 1/2. So your final answer is 1/4. Or you could say to yourself, oh, well, when I plug 0 into this, sine of 0 over 2 times 0 is still another 0 over 0. So you could do L'Hopital's again. So either you notice this sine x over x, except they're y's now, and you notice that that's 1, or you notice that you have 0 over 0 and do L'Hopital's again. Well, the derivative of sine is negative cosine. The derivative of 2y is 2. So now when I plug in 0, now when I do my limit as y goes to 0, I get negative 1/2, right? And I lost a negative somewhere, didn't I? Or did I? Oh, I'm sorry. The derivative of sine is just cosine, not negative. Right? So either way, I'm getting 1/2 times 1/2. Okay? All right, so those are some things you have to do to evaluate a limit when it actually works. But sometimes you can't do that. Okay? So when the limit is not so easy, there's some different things that we have to check out to evaluate the limit. So recall from last year that when you calculated the limit of a function, the answer had to agree from the left and the right side. So basically, like when you had a problem, and like let's say you had a problem that went like this. It came over here and it went like that. And so this was like at 1. So the limit at 1 didn't exist because you did not agree, correct? But when you had a problem that like maybe came here and then did some weird thing and went like that, and let's say this was 1, you're fine. You're like, oh, we're both coming to the same place. So the limit existed. Also, you had a thing where, you know, let's say you came here, there was an open, and it went there. So the function didn't exist, but the limit still exists at 1. So the left and the right side have to agree. And because you were two-dimensional, you were on a flat surface. Well, now, we don't have just the left and the right side. We have all kinds of different directions that we can come from. We can come from like any direction basically that we want to go from, all right? And so not just the left and right, we can come along any direction. And I'll show you some pictures in class next time just to kind of like show you more what I'm talking about. But what we have to do is instead of going along the left and the right side, we can come along any value. All right, so this is what, so just bear with me here. We'll do a couple and then you can kind of see what's going on here. All right, now remember, they have to agree. So what we're going to do, and I'll tell you like a summary of like which ones we should test, because you're going to be like, how do I know which one to do? Well, you'll know in a minute. I'm going to tell you which ones we do, and then usually what's going to happen is they don't exist, but let's just see. So we are going to do this. We are going to go along certain lines, all right? So along the line x equals 0. So basically what I'm saying here is that x is 0. So if I'm going along the line x equals 0, both of these things in my problem are now 0. Because so basically what I have right now is the limit as y goes to 0, because I'm supposing x is 0, because like that is part of this curve here, or this function. So when I imagine that x is 0 along that line, I'm imagining when this function intersects the line x equals 0. So x is 0, so that means the top expression turns into 2y. The bottom expression turns into negative 2y. Right? So I end up getting the limit as y goes to 0 of basically the y's cancel out. I get negative 1 here. So my answer is negative 1. So when the line x equals 0, or the plane, I guess, intersects this function, so along that line, or along that plane, the limit as y goes to 0 is -1. So if I try a different plane that you're going along, or a different line to go along, it has to be the same answer. Okay, so now I'm going to try it along y equals 0. Okay, so along y equals 0, I am going to basically pretend that these are 0. So I get the limit of only the x's, and x is going to 0. And if y is 0, then these two things go away, so I have just x over x. Well, that's the limit as x goes to 0 of 1, and the answer to that is 1. So look at that. I have a mismatch. When I went along one thing, my function, the answer to my answer was 1. When I went along another direction from another plane that it intersected with, I got -1. So that mismatch means it does not exist. So therefore, it does not exist. The limit does not exist, because you can approach this place in two different ways and get two different answers. Okay, it doesn't match. All right, so let's try one down here. So this time, when I go ahead and I do along x equals 0 and along y equals 0, look at what I get. If x or y equals 0, then my whole problem just basically falls apart and I get 0 on top, right? So if x equals 0, I'm doing the limit as y goes to 0 of, the whole top turns into 0, so I have 0 times y squared over x is 0, remember, 0 plus y to the 4th. Okay, so what I end up getting is I get the limit as y goes to 0. The top is 0, so 0 over y to the 4th is just 0. So my answer is 0. Okay. Same thing happens to me over here. If I'm doing along y equals 0, I still got x going to 0 here. If y is 0, I get 0 on top, and I get x squared plus 0, so I get x squared. Well, 0 over x squared is 0, so that one, like this whole thing is 0, so I get the same thing I got over here. So I get 0. Okay, so those matched, but we can't just try any old thing. Okay, so now there's and we're gonna do this the next couple things here, but we're gonna do it this way, along y equals x. So this means that every y is going to turn into an x, or every x is going to turn into a y. It doesn't really matter which one you do. So I'm going to make all my y's into x's. So I'm going to keep my x's. So I'm going to be doing the limit as x goes to 0. So x is still 0. All my y's are going to turn into x's. So this will be x squared times x. So that's x to the 3rd. This will be x squared plus x to the 4th. Okay. All right. So this has turned into a rational function. Also, we could do, this is not infinity, I was thinking that, sorry about that. Let's go ahead and do L'Hopital's, because when we plug 0 in here, I end up getting 0 over 0. So let's do L'Hopital's for this. So when I do L'Hopital's, I get 3x squared. The bottom turns into 2x plus 4x to the 3rd. Well, if I plug in 0, I get 0 again. So let's do L'Hopital's again. I do it again, I get 6x over, this turns into 2, plus, and then the, let's see, 12x squared. All right, so I'm still doing my limit there. I probably should be writing limit there, but I didn't. All right, so now look, I have the limit as x goes to 0. Now I can plug in a 0, because the top turns into 0, but the bottom is a 2. So 0 over 2, 0. Okay, all right, so it's looking good. Look, I got 0 all these times. All right, so there's another thing we can try. Let's try along the function y equals x squared. Okay, all right, so bear with me. I'll like do this one, and then we'll start like one more. We'll like do this one, and then we'll stop. All right, so y equals x squared. So all the y's are going to turn into x squareds. So I have the limit as x is going to 0, so I'm keeping this guy, and all the y's are x squareds now. So I have x times, this y is a y squared, so I get a I get an x squared inside that square. All right, and this is x squared the same, plus, now I got an x squared inside the 4th power. All right, so let's clean this up. So I got 4, 5 on top. I got x to the 5th. On the bottom, x is going to 0. I got x squared plus x to the 8th. All right, so let's see. I end up getting, if I start my L'Hopital's, I get 5x to the 4th over, I get 2x plus 8x to the 7th. Okay. All right. And so, you can see by this last one here, oh gosh, no. Sorry about that, my screen went off, and so I think the video was going to stop. All right, so here we go. So you can see based on what I was doing here, I'll do one more derivative, and the top will be 0. This bottom would turn into a 2, kind of like it did here. So if I did L'Hopital's one more time, I get 20x to the 3rd. The bottom will be 2 plus, what is that, 56x to the 6th. So I'm going to have 0 over 2 again, so 0. Okay. So everything's looking good. We got to do one more. All right. So let's do along x equals y squared. So this is going to be the last problem, actually. All right. So x is equal to y squared. So I have my limit. This time y is going to 0. So all my x's are now y squared. So this is a y squared times a y squared. So y to the 4th. My x's is a y squared, so y squared squared will be y to the 4th, and that y to the 4th is staying. All right, so now look what happens. I get y to the 4th over 2y to the 4th. And these y to the 4ths cancel. So that whole part there is just a 1/2. So the limit of 1/2 is 1/2. And that right there is a sad face, because all these were 0, and then we got a 1/2. So that's a does not exist. Now you're like, well, how would I know to use all those things? So usually it'll turn bad before that, but let me tell you the ones that you're going to use to prove. You're going to use x equals 0. You're going to use y equals 0. You're going to use y equals x and y equals x squared and x equals y squared. If you do all of those 5 things and nothing changes, everything's the same answer, and we're just going to stop there. Okay? All right, so we'll finish up this in class. Your only job tonight is to have these notes taken and to finish section 15.1. I'll see you in class. Bye-bye.